Number 16. The parallelogram-shaped lot of land shown in the right is put up for sale at $2,100 per acre. What is the total price of the land? Well, first we've got to find the area in square feet and then change it over to acres. So when you have a parallelogram, its area is its base times its height. So it's 314 times 293 square feet. So it's 314 times 293 is 92,002 square feet. Okay, 92,002 square feet. We've got to change that to acres. So 92,002 square feet times, we want our answer to be in acres, and we want to get rid of those square feet. And they give us exactly what we need, is that 1 acre is 43,560 square feet. So I've got 92,002 over 43,560 acres. Okay, and then whatever I get, I have to multiply by 2,100, because 2,100 per acres. So 92,002 divided by 43,560 is 2.1121 acres. Okay, acres. Multiply that by 2,100, and I'm just going to leave the whole decimal. I didn't even round it. I'm in my calculator. Times 2,100, and to the nearest dollar, it's $4,435. So we have to get the area in square feet first, change the square feet over to acres, multiply each acre that we got, which is about 2.11, times the cost of 2,100 per acre, and that's where we get the 4,435. Example 17. A 3-foot by 3-foot rubber shop mat costs $43. A 3-foot by 4-foot foam mat is $39. Which has the lowest cost per 1 square foot? Okay, well, let's find the square feet first. If you've got a 3 by 3, that's going to be 9 square feet, right? That's a square, so length times width or side squared is 9 square feet. You've got a 3 by 4, so that's 12 square feet, okay? We want the cost over the square feet. So it says cost per square foot. So the first one is 43 over 9, and the second one is 39 over 12. All right, we're going to get approximate costs here. 43 divided by 9 is about $4.78 per square foot. 39 divided by 12 is $3.25 per square foot. So the cheaper one is the foam. So the foam has a lower cost by how much? Well, 4.78 minus 3 1/4. You save $1.53 per square foot. So the foam mat is the cheaper by $1.53 per square foot. Okay, number 18. Find the missing dimension of the figure shown to the right. Round to the nearest tenth. Now, if we knew the area of this triangle, it still wouldn't do us any good. We couldn't find that length. If we knew the total perimeter, though, because we're looking for a length, we could find it. But there's also this thing called the Pythagorean theorem, which is true for right triangles only. So notice I got a little right angle in the corner, like right here. What it says is that a squared and b squared, that you've got sides of a, b, and c, and that a squared plus b squared has to come out to c squared. This is called the Pythagorean theorem. The Pythagorean theorem. So for us, we know 9 squared plus 14 squared comes out to this c square side. So that's 81 plus 14 squared, 196, equals c squared. So c squared, 81 plus 196, is 277. And to find c, I have to take the square root of 277. Now, that's the exact answer, but they want us to give it to us approximately to the nearest tenth. So to do the square root, you press second and x squared, and then type 277. Second x squared, 277, is about 16.64. So to one decimal place, 16.6 inches. Now, we're not finding area, so we're not trying to measure the squares. We're just trying to find a single length, so that's in inches. Number 19. Find the missing dimension in the figure shown to the right. Type an integer or a decimal. And again, we have a right triangle. So this is A, this is B, and this is C. Now, C is always across from the right angle. It's the longest side. So A squared plus B squared has to be C squared. A we don't know. B is 18 squared. C is 27 squared. So A squared plus 18 squared, 324, equals 27 squared, 729. So we got to get that A squared by itself. Subtract 324, we get A squared is 405. And so A is approximately the square root of 405. So I do second x squared 405, and I get to one decimal place, which is what they asked me to do, 20.1 inches. Again, we're not trying to find area. We're not trying to cover it. We're trying to find a length, so that'll be in inches. Number 20. Find the missing dimension in the figure to the right. Type an integer or decimal. Round to the nearest tenth if necessary. Now notice this time they did give us area. And we know the formula for area is 1/2 base times height. We know the total base is 20. We know our height is missing, but we know our area is 162. So I just substitute in for the things that I know. So 162 is 10 times h, because half of 20 is 10. Divide both sides by 10, and 16.2 is my height. So 16.2 feet, not square feet. We're not trying to cover it, okay? We know how much it would take to cover it. We're just trying to find this length of this single thing, the height of that triangle. So our final answer is 16.2 feet.